Hello everyone, tonight's Chemistry Night Before News has some common errors to avoid and a couple of common questions that crop up on paper 2. So first of all, just a few common errors to avoid when answering extended writing questions. Make sure you read the question carefully and identify the command word. What exactly is the question asking you to do? Describe, say what it looks like, explain the hows and whys, or calculate. If it asks you to calculate a mean, add the numbers together and divide by the number of numbers. State a range of data. That's the difference between the highest number in your data and the lowest number in your data. And if there are any anomalies, don't include them in your mean, or redo that part of the experiment in order to get more accurate data. Common errors to avoid in graph tasks. First of all, check how many things it asks you to do in the question. So it generally asks you to do at least 3 things: plot the data, label the axes, and draw the line of best fit. The label for the axes are generally in your results table. Independent is usually the first column, and so therefore the title, that would be the title with the units for your x-axis. Secondly, don't include the anomalies in your line of best fit. I've done an example on a question further on in this video. Interpret the scale on both axes before plotting the data. That way you know you'll be accurate. And plot the data and draw the lines of best fit in pencil, just in case you make a mistake. And at the end, go back and check that you have plotted your data points accurately. And finally, check how many marks the question is worth, and that's generally in brackets at the end of the question. That way you can make sure you've included enough points in your answer to achieve that many marks. Be specific. Do not refer to chemicals as it or them. Use the name of the element or the compound you're referring to. And use your every method for calculations. This way, if you get a little part of it wrong, you'll still get some of the marks. And if you make a miscalculation when you put the numbers into your calculator, again, you'll still get partial credit. That was the biggest topic that we did in chemistry in year 11. Hopefully at this point you have already secured the core knowledge on the 3 different ways of how to measure the rate of a reaction. For example, you could measure the volume of gas that's produced. Alternatively, you could measure the change in mass of the reactants or the products. And thirdly, you could measure the production of a precipitate. The question that I'm going to look at today is the third option. And this question is about the reaction between sodium thiosulfate solution and hydrochloric acid. They give you the symbol equation, and equally they've included the state symbols. And this is a little bit of a hint, because the question goes on to ask you, the mass of the conical flask decreased, explain why. When you look at the state symbols, you can see that sodium sulfate is an aqueous solution. So is hydrochloric acid, and so is sodium chloride. So they can't possibly escape out of the flask. We've got water, which is a liquid. And then we can see that sulfur dioxide is produced, which is a gas. That's the only product that will be able to escape out of the flask on its own. And then finally you have the production of the solid, which is the precipitate, which made the solution go cloudy. So, answering our question, explain why. Firstly, you need to state that sulfur dioxide was produced. And secondly, this question's out of 2 marks, so you must say that that was the only substance that could escape out of the flask. So, sulfur dioxide was produced, which escaped out of the flask. Don't leave it too ambiguous or too vague. There will always be some kind of graph question on the rates of reaction section. In this one, they've given you the results table and want you to plot the data. Sometimes they will just give you the line of best fit and ask you to work out various bits of information from the graph. If you are given a results table, make sure you look carefully at what the names of the columns are and that you can interpret the information that's in it. In this results table, we have temperature in the first column, and we can see that temperature increases as you go down the column, goes from 25 degrees all the way up to 85. In the second column, we have the time in seconds, and that's how long it took for the reaction to complete at that temperature. So, for example, at 25 degrees, it took 89 seconds for the reaction to finish. At 55 degrees, the temperature had decreased to 17, and at 85 degrees, the time had decreased to just 4 seconds. So in summary, as temperature increases, the time taken decreases, and therefore the rate of the reaction increases. Once you've plotted your data on your graph, and you've been careful not to go over the minor grid lines, then you can go ahead and draw in your line of best fit. Make sure your pencil is sharp and that you've got a rubber handy, because you need to make sure that it goes through the points as close as possible. Now, always start within the graph paper that's provided. Do it lightly in case you have to rub it out. It's quite difficult doing it on a screen, but hopefully it'll be a little bit easier for you when you've got it flat on a desk. One of the major problems that I picked up in Mock 1, where there was a graph question, was when the data had an anomaly. And so you might end up with something like a data point up here that sticks out. If you've got an anomaly in your data, do not include it in your line of best fit. So, in other words, do not do that. That is wrong. Do not count it, do not include it in your line of best fit. You bypass it and join it up with the others that are in the pattern. Equally, they could ask you about the anomaly. How do you deal with an anomaly? There are two things that you can do. Firstly, you can not include it when calculating the mean. And secondly, you can redo that little part of the investigation, and so that you get a more accurate result. The third part of the question asks you to draw a tangent at 0.20 moles per decilitre cubed. The best advice I can give you for this is to make sure you use a ruler, and make sure that when you're drawing your tangent line, that you extend it on either end so that you can draw a larger triangle to make your numbers easier. Secondly, you can extend your lines so that they coincide with major grid lines, again so that it's easier to read the numbers. The way to calculate the slope of a gradient is the rise divided by the run. And so in this case, our rise is 36, and our run going across the bottom is 0.43. So we put that into our calculator, work that out, and make sure when you are writing the answer that you always include the units. And that comes to 83.7, 2, and that would be molecules per dm cubed. Finally, on this section, there is always a question where you have to explain why the rate of the reaction increases or why the rate of the reaction decreases. And your answer is based on collision theory, which states that the more concentrated or the higher temperature or the larger the surface area, the higher the pressure, the more likely there is of a collision. Particles with more activation energy are more likely to have a successful collision, therefore the quicker the rate of reaction. And so this particular one is asking why the rate decreases. And the rate decreases because there are less active particles per unit volume. That's a phrase that you could really do with remembering, because you can use that, it gets to the point, and it adequately explains that it's the number of particles in the volume of substance that you've got. So it reflects the ratio that you're trying to speak about. And then because of the lower concentration of sodium thiosulfate, then the frequency of collisions decreases. So 3 things to make sure you include, less active particles, less collisions, and therefore a decrease in the rate. The next section is a question on reversible reactions. And on the title slide, you can see in black the general word equation for a reversible reaction. And what this means is, as reactants A and B react together, they produce products C and D. That would be described as in the forwards direction, or the reaction was towards the right hand side. Products C and D are reacting at exactly the same rate as A and B are reacting, and it's important that you describe it as the same rate. And therefore the reaction in the opposite direction produces the reactants, or the original reactants. And a thing to make note of is the reversible reaction symbol. Just make sure that you do get your arrows only half an arrow on top and half an arrow at the bottom. An example here, which your teacher might have shown you in class, is where we have hydrated copper sulfate. In the forwards direction, it's endothermic, which means it takes energy from its surroundings, and it produces anhydrous copper sulfate plus water. At the same rate, the anhydrous copper sulfate and the water react together, and the reaction in the reverse direction is exothermic. It's the opposite of whatever is in the forwards direction, and that means it gives out energy to the surroundings. And the products of this reaction make the original reactants over here. So at the top in black is the general word equation for that, or the general symbol equation for that. This question uses the example of carbon dioxide in fizzy drinks, and it gives you the symbol equation including the state symbols. Carbon dioxide is a gas, H2O, which is water, is of course a liquid, and it makes carbonic acid over here, and it gives you a space to write in the state symbol for carbonic acid. Now it tells you in the question it's an aqueous solution, so hopefully you could deduce then from the options that have been given underneath, choose the answer from the box, that it is in fact aqueous, and it asks you to write it in, so make sure you write it in the space provided. Quite often on these types of questions, people will miss the direction in the question, and sometimes it can cost you marks. Part B, which ion causes carbonic acid to be acidic, and this draws on the year 10 knowledge of acids and alkalis when you studied neutralisation, and hopefully by now you should be able to distinguish that an acid always has H plus ions and an alkali has OH negative ions. The second part of the question asks you about a different substance, which is ammonia, which is produced from nitrogen and hydrogen gas in a reversible reaction. It gives you the word equation this time, and the knowledge they want you to come up with is can you make a formula given the word equation and what the molecule looks like. And don't overthink a question like this. Quite simply, nitrogen has been labelled for you and there is only one of them. And so nitrogen is an element on its own, so it's a capital N. And we have 1, 2, 3 hydrogen atoms, N, capital H, little 3 at the bottom. The skill on the multiple choice questions is not overthinking all of the answers. This one is quite straightforward and the actual one stands out. When does a reversible reaction reach dynamic equilibrium? And this requires you to be secure of the knowledge of Chatelier's principle and be able to recall the definition of a reversible reaction. So in this one, when the forward reaction and the reverse reaction happen at the same rate. Rate is the key phrase that you always need to look out for. On the second part, which condition is needed for the reverse reaction between nitrogen and hydrogen to be at dynamic equilibrium? And if we read through the answers, generally at least one of them will stand out that you can eliminate. So which condition is needed for the reversible reaction between nitrogen and hydrogen to be at dynamic equilibrium? And in a closed system, it means where no gases can escape and no gases can enter. So the first two really don't fit. You can eliminate them straight away, and it leaves you with your last choice here. The last part of this question requires a written response. So choose your words carefully because there is a very specific definition for the parts of the topic that are addressed in these questions. So make sure that you have checked over the keywords for reversible reactions. Now, G asks us, how can the direction of a reversible reaction be changed? And this answer is exactly the same as the factors or the variables that affect a rate of reaction, which is change in temperature, change in pressure, or change in concentration. Any one of those three rather than change in surface area. H, iron is used as a catalyst in the industrial production of ammonia. I left this question in because this question, or how does a catalyst work, it will always be on the paper 2, on the chemistry paper 2. Why is a catalyst used? And it's used because it speeds up the chemical reaction. How does a catalyst work? And that provides an alternative pathway and increases concentration. So you'll get one or the other type of question on paper 2. The last question is a percentage, and you will always have some form of a percentage question that crops up on paper 2 as well. Now this one is quite straightforward. There's 2 ways which you can do it, and I'll show you that once I've bugged the question. So just like we have done in science lessons, box off what the command is. In this case, it tells you to calculate the mass of ammonia used each year to manufacture fertilizers. When we read the other information, it tells us that in total 150,000 million kilograms of ammonia is produced, and that 85% of that 150,000 million is used to make fertilisers. And so in order to calculate the mass of ammonia used each year, we need to find out what 85% of 150,000 million is. There's two ways in which you can do it. You can either break down the 85% in your initial part of the equation, 85 divided by 100, and then times by 150,000. Or you can do 150,000 divided by 100 and then multiply that by 85. Either way, your answer comes to 127,500 million kilograms. The main thing with the percentage, if you do get really overwhelmed in the exam, just remember when you are calculating your percentage at the end of a test, you always divide your score by the total score of the test and then times it by 100. So in other words, part of what it is you're trying to find divided by the whole amount times by 100. And if you can recall that in an exam, then you can manipulate that little equation when it comes to things like calculating 85% of 150,000 million kilograms. The next section is from the using resources topic, and the images that are on the title slide is potable water. Remember, it's potable, P-O-T, not portable. Potable water is water that is safe to drink. Don't forget, pure water is where you have only one element or compound. And potable water has dissolved salts in it and minerals, and so it's potable, not pure. The second image along is showing you the water treatment plant, and the last image is showing you a life cycle assessment image. Make sure you are able to recall the steps involved in producing potable water, in producing potable water from wastewater, because don't forget, once it's been treated, it goes back into the rivers or the estuaries or the sea. And then the life cycle assessment, make sure you can recall all 4 stages. The first part of this question is a bit of a gift because it gives you a diagram, and there's always plenty of information to help you with your answer in a diagram. Sometimes when you look at it and in the heat of the moment you might think, yeah, it's got the four different sections of treating sewage, but when you look closely there are quite a few things that can give you a prompt. First of all, if you have a look at tank A, there's 2 things going on. It's got a metal grid, and then at the bottom it's got sediment. So you can immediately put on your diagram, we've got screening, which is the first part of the treatment, and then at the bottom, if you remember, we call that sedimentation. And that's where the finer particles sink to the bottom and are filtered off. In tank B, it now becomes known as effluent. Make sure if you have to describe that in a question, you can use the right term. As we go further down the diagram, we can see in tank C there are air bubbles. And so that must mean that is where the aerobic digestion takes place. Don't forget, aerobic, A-E-R-O-B-I-C. And then in the second tank, that is the anaerobic treatment. So before you've even got into your questions, you've almost recalled all the steps, and the images have given you a prompt. Name the 2 processes happening in tank A, screening and sedimentation. Explain the processes happening in tank C. Well, you've already established that the effluent is undergoing biological treatment, and if you remember that with oxygen it's aerobic, so you've got oxygen that is being used for anaerobic respiration, used for aerobic respiration. And this is the tricky part where people sometimes go wrong. And it's by microorganisms. Refer to them as microorganisms. And their job is to digest waste. Don't get confused with killing pathogens. That's in the next stage when they sterilise the water. So it's simply digest waste. The water from tank D is sterilised. They're going to ask you about this because they are looking for a specific answer. And that's why I say it's only at this point then you should refer to the sterilisation step to kill pathogens or to kill bacteria. Seawater can be desalinated by distillation. Name one other method of desalination. And in your lessons, there was only two things that we actually taught you, and that was, in addition to distillation, we used reverse osmosis. The very last slide question that I've included is because quite often they will include a question that requires you to recall knowledge again from year 10 and be able to calculate the concentration of a solution. This question, the salty seawater contains sodium chloride. The scientists collected 3.3 grams of sodium chloride from 175 cubic centimetres of salt water. Calculate the concentration of sodium chloride in grams per litre. So the first thing is, what is the formula that you need to use? And the specific equation for this is concentration equals the mass divided by the volume. Just like any other kind of calculation like this, we're going to use the every method. So make sure you start off by bugging the question. So box off the command. It's asking us to calculate the concentration, so we know which variable it is in a minute, which we're calculating. The scientists collected 3.3 grams, that's got to be the mass, of sodium chloride from 175 cubic centimetres. Anything cubed means it's 3D, so that's got to be the volume of water. So, as with any kind of equation, we always start by putting our every method. E for equation, V for the values of the variables. Our second E with substitution, that's where we put the numbers from the question and the values line into our equation. And then finally, R and Y stand for results and units. The equation is concentration equals mass in grams divided by volume, and that is in litres, dm cubed. Our values for this equation come from the question. Concentration, as we've already discovered from boxing it off, is what we are calculating, so we put a question mark. The value for mass from the question tells us it's 3.35 grams, and the volume is 175 centimetres cubed. Now the question has told us they want it in litres, so we need to convert 175 cubic centimetres into litres, and we do that at this stage by dividing by 1,000, and therefore our value for this becomes 0.18. it's 0.17 that was reoccurring, but we need to round it up to 2 decimal places because the numbers in the question are 2 decimal places. Now we're ready to rewrite our equation with substitution. So we literally rewrite what is in the first step, but we put our numbers in it. So concentration equals 3.35 divided by 0.18. Put that into your calculator and you will get an answer of 18.61 reoccurring. So our final answer, again, 2 decimal places, just like the figures in the question. And of course, we must make sure, if they don't give you the units, which they actually do here, you must make sure that you always include the units. The last point though, if you were to write a wrong answer and show no workings out, you wouldn't get any marks. If you made a simple calculation error but had done the right equation, you just put a wrong value, let's say, in here, but you'd done everything else right, you would still get partial credit. So it's always worthwhile using the every method if you're not very confident. And if it's a complicated question and you are confident, definitely do the every method to ensure that you get the maximum amount of marks that you can. I hope this has helped. Good luck tomorrow.